Let's take a look at this phone. The back is shattered badly. The top here is already deformed. The screen is so shattered it's unrecognizable after falling off an electric scooter and then being run over by a truck. This iPhone 13 mini, can the data on this phone be saved? Under what circumstances can we save our phone's data, and in what situations is it lost? Today's video contains a wealth of knowledge. I recommend that every fan watches till the end. Anyone who sees this is a loyal fan. If you think the video is helpful, please like and repost it. Thank you. Let's turn on the screen and take a look. This phone is being taken apart for the first time. It has never been repaired before, and just by looking inside, it's very neat. You can't tell at all that it's an iPhone 13 mini run over by a truck. Let's first remove the screen. If you like this video, please send me some TikTok gifts. Thank you. After removing the screen, we see that it's completely broken. After removing the screen, we see that the top of the midframe is indeed cracked. It indicates that this was the point where the force was concentrated. So why do we choose to directly dismantle the device instead of plugging in a charger to test, charge, etc.? A fan said that the data is very important. When the motherboard's condition is uncertain, trying to charge it might burn other components. If the data is important, then nothing else matters. So first we need to remove the motherboard and take a look. Upon further disassembly, we discovered it's a US version. The US version has a millimeter wave antenna, therefore we need to remove the battery. Then remove the millimeter wave antenna. This millimeter wave antenna is also blocked by the rear camera's ribbon cable, so we also need to remove the rear camera. If you think the video is helpful, please like and repost it. At this point, we can successfully remove the motherboard. Let's examine the back of the motherboard. The antenna soldered here is the millimeter wave antenna. Let's take another look at the motherboard. The motherboard clearly has some slight warping, especially around the CPU area. Let's first use the power meter to check. At this point, we find a short circuit when measuring. Is it really that simple? Let's use a multimeter to test the resistance between the positive of the battery connector and the board. The first end is normal. We found that the short is at the second end. So at this moment, we need to separate the motherboard layers by peeling off the foam and stickers on the board, then place it on a heating platform and heat to separate the upper and lower layers. Some people quietly watch brother fix the phone, but they secretly like, comment, share, repost, and follow. These people are truly lovely. After separating, let's examine the upper and lower layers. It's clear that there are signs of detachment. These are signs of solder joints coming undone after the drop, after cleaning. Let's inspect the upper layers separately. Look closely. This is the point of force concentration. The bending is exactly on the back of the CPU, so if the CPU is damaged, then the data cannot be saved. After separating the layers, let's power up just the upper layer and see. We find that the single upper layer no longer shows a short circuit on the meter. But when pressing the power button, there's obvious leakage and it does not boot. We immediately understand what this current means. This is also repair experience. Let's observe with a thermal imager. The lower left corner of the CPU and the area near the center are extremely hot, up to over 100 degrees. Then when the ammeter resets to 0 again, it starts over, cooling down then heating up again. Because the phone's data is very important, we don't need to repair the leakage on this board again. Because the device also has a bit of leakage itself, messing around further on this motherboard might also risk losing the data. So we choose to directly remove the CPU, the storage chip, and the logic chip from the motherboard and transfer them to another board to achieve the goal of booting while preserving data. We heat up and carefully remove the A15 CPU. After removing the A15 CPU, we treat all the solder points on the back of the CPU and scrape off the black adhesive above it. If you think the video is helpful, please like and repost it. Then we remove all the solder from the CPU solder points and then rib all this. A 15 CPU with new solder balls, heat and blow to melt every detail of the CPU. If you think the video is helpful, please send me some TikTok gifts. Thank you. After processing, let's remove the storage chip from the motherboard. Apart from the CPU and storage, there is one more very important component, which is the logic chip. Without it, the phone can't boot. We also rib all the storage chip with new solder balls. Then let's first install the storage chip onto another motherboard that we know is good. Next, we install the CPU. We apply flux to the CPU solder pads, then heat and solder the A15 CPU. After soldering is finished, the exciting moment is coming. Let's first check with the power meter. We find that there's no more leakage when powering on. Press the power button. The startup current is much smaller than before, but it's still abnormal, and it still doesn't boot. We carefully observe this current, and experienced technicians know this is the current from the upper board. That is, the current of the non-functional temporary storage. We continue to observe with the thermal imager and find that both the bottom and top areas are heating up. So this fault might be due to damage to the top layer of the CPU's temporary storage, or the CPU itself might be damaged. But in order to save the customer's data, we can only try again. We seal the bottom of the CPU with UV glue because we need to grind off the top layer to prevent dust from entering the bottom of the CPU. We place the motherboard into a grinding machine, select the iPhone 13 mini CPU in the program, and click Start Grinding. If you think the video is helpful, please like and repost it. First, the grinder performs a rough grind, after which it'll perform a finer grind, since the CPU's top layer, which is the temporary storage, is as thin as A4 paper. Grinding is the best method. After both grinds, we manually grind a bit more until the solder points are exposed, then we've finished grinding. Let's take a look at the result after grinding. We still need to smooth out the solder points on the top layer to ensure nothing goes wrong. We also need to put the motherboard in cleaning solution and use ultrasound to clean it. At this point, we try powering it on again. The exciting moment, it's very, very lucky. The startup current is now normal, but since there's no top layer, there's no temporary storage, so the current is like this. We just need to smooth out the solder pads for the CPU's temporary storage because only once they're smooth can we solder new temporary storage. So where does the new temporary storage come from? We take a discarded CPU and grind off its bottom layer directly, placing it in water for grinding because grinding creates a lot of dust. So finally we leave just the top layer due to time constraints. We go straight to solder ball reflow and soldering. After finishing, we directly use the single upper layer, connect the screen, connect the battery, and see if it powers on normally. Okay. At this moment the Apple logo lights up successfully, indicating that the CPU's temporary storage has been replaced perfectly. Enter the passcode, but for a phone with a lock screen passcode, the NFC is on the lower layer, so at this time it will prompt to restore data without the lower layer. It will continue restoring data and can't reach the home screen, thus data cannot be exported because the fan's original lower motherboard was short-circuited. We no longer attempt and instead directly replace it with a known good lower layer, thus powering on, even without a Wi-Fi modem. As long as the NFC works normally, it will reach the home screen. Okay, we now plug in the charger, and we're extremely lucky as we've successfully saved the fan's data. Although there's no Wi-Fi, no Bluetooth, no network, and no modem, it can't make calls, the data is there. This is very fortunate. Looking at it, it's a 256 GB US version iPhone 13 mini, consistent with what the fan described. So we also need to connect the old screen's digitizer ribbon cable, then connect it to the computer, because without the digitizer, it would reboot every 5 minutes. We connect the phone to the computer and find that iTunes cannot backup without a modem, so we choose another tool to back up the entire phone directly. After the backup is complete, the fan then directly chose to purchase a second-hand iPhone 14 from me, so next it becomes simple. We import the entire backup data into this iPhone 14. If you think the video is helpful, please like and repost it. Okay, after the import is complete, all the data has been fully restored to this new phone. All the data is there, so I advise everyone to definitely get into the habit of backing up your phone data, because if something happens to your phone, our data will still be on the computer. Thank you all for watching.